Good morning, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. The session will run over the next 60 minutes, including Q&A. Please post all your questions in the chat section, and our speaker will try to answer most of it. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. I would now like to welcome Dashleen, our speaker for today's session. Dashleen has been working in Microsoft Azure App Technologies for the past 9 years and providing solutions to the developers across the world who are using Microsoft Azure as cloud platform. She has been working on PAAS technologies, networking of apps with on-premises resources, Service Bus, VMs in Azure, and many more. She is also a Microsoft Certified Trainer. But for now, I will hand over to Dashleen to begin the session. Let me bring Dashleen into the StreamYard. Hi,
Thank you.
Dashleen, over to
Thank you,
you. And
Rashmita. Okay, hi. Good morning, everyone. Just doing a quick check if you can hear me. You can type in yes or no. Okay, thank you. We'll start with the container offerings in Azure's session. But before that, I would just like to uh, give a brief idea about the virtual machines before we move on to containers, and then we'll try to understand why did containers come into the picture and what's the difference between a virtual machine and a containerization of the application. Okay, so my name is Dashleen and I work as a Azure customer engineer for Microsoft. I have 12 years of IT experience. It's been 9 years in Microsoft, and I've been working in Azure application design and development throughout. Um, so let's start with virtual machines. So we all know that we can provision virtual machines in Azure. We just need network configurations, VM name, where do we want to provision the VMs, the location of the VMs, the size. I'm going to explain you the pricing model and how to choose the storage and the operating systems while you provision the virtual machines. Sorry. So when we provisions the virtual machines in Azure, we have to specify the name. We can choose between Windows VM or Linux VMs. Windows VMs can go up to 15 characters and Linux VMs can go up to 64 characters. Uh, Now, it's a good idea because we may have many virtual machines to always name the user naming convention for our virtual machine so that we don't mess up between dev and prod. We can use several naming conventions, like you can name them according to the role or the environment, location, etc. The most important thing over here is there are two primary costs involved for every virtual machine. Now, one is the storage cost, and the other one is the compute cost. So, compute is based on the time that the VM has been provisioned for. Let's say you have been using VM for 15 minutes, you'll be charged for 50 minutes. If you stop or deallocate the VM, you'll not be charged for it. However, the storage cost, you will be charged for the storage the VM is using. That's the virtual hard disk. Even if your VM is stopped, you will be getting charged for your storage. You can only get rid of the storage cost if you deallocate the hard disk. There are two payment plans. One is pay as you go, and the other one is the reserved instances. So, pay as you go is the most popular plan offered by Microsoft. That means you need to only pay for what you are using. Let's say you have been using 5 VMs for first 10 days of the month, and thereon you are using only one VM, so you'll be charged accordingly. The second option is the reserved instances. There, we all know there is a there is a crunch of VM, we may not instantly get the VMs in the data centers or the locations that we are looking for. So if you anticipate high usage in during the holiday season, or let's say next year, according to your app's traffic, you can reserve the instances. You can visit azure.com pricing and you can reserve the instances. It works out cheaper, and you'll be rest assured. Let's say if you need 100 instances, you can reserve it at a particular location. There are storage options given to you when you choose the virtual machines. It can be standard or premium storage accounts. That depends upon the workloads that you are running on your VM. And you can also choose between managed disks or unmanaged disks. It is always advisable to go for managed disks because therein we don't have the headache of managing our disks. Azure itself manages our disks efficiently. If it needs, it adds on more disk. If it doesn't, it just removes it. And our billing is also maintained in that way. Now, there are a number of ways we can go ahead with the Azure virtual machine creation and management. We can use Azure portal. Let's say you want to provision 50 to 100 virtual machines in one go. You can use Azure Resource Manager or PowerShell scripts. You can also use CLI, or you can also write your own APIs. The graphic user interface is available on Azure portal. You can It looks like this, and we can go ahead and create the virtual machines from the portal. Okay, this is a sample PowerShell on how to create Azure virtual machines. Now, there are options, the configuration options while you create VMs, like memory, disk storage, networking, availability. Depending upon the service level agreement, that's the SLA, you get the uptime for your VM. Let's say you have two VMs, you'll get 99.9%. If you go with different zones of deployment, you get 99.99% of availability. You also have memory and disk storage to use for that depends upon the workloads that you are running. Now, there are several options available in VM categories. There are general purpose VMs, there are memory optimized VMs, high performance VMs. That depends upon the usage that we need. Let's say we are using high performance computing application. We may not go for a general purpose VM. Okay, so this is just a screenshot from the Azure docs. It's available online. That depends upon if you need high CPU, you'll go for compute optimized. If you need high memory, you need a memory optimized VM, and depending upon the usage. Now, coming to containers, the session is for. So, why was I explaining VMs? Is because initially we were using a lot of virtual machines. We used to create virtual machines using Hyper-V. Even on our local computers, we could create virtual machines. But then there's a popular concept which is called containers, and we are trying to move from virtual machines to containers. To understand containers, we need to have some basic idea about virtual machines. So if you look at this slide, this is how the virtual machines were created. We used to use a Hyper-V or any other hard software to create the virtual machines on our computers. Now, the major difference is when you create virtual machines, the kernel sits inside the virtual machine. The operating system kernel is inside the virtual machine. So let's say you are on a Windows machine. When you create a virtual machine on that Windows computer, the kernel of that operating system will sit inside the virtual machine, and you'll get another virtual machine which has the Windows operating system. Okay. Now, what is container? Container, when we create containers, it is an isolated, lightweight unit for running your application. The major difference over here is you can only lift and shift your application and the services that your application needs inside your container. The kernel and the operating system will not sit inside the container. So that is why it is called lightweight as well. Now, the containers, when you deploy the application on the containers, it is also said that they are platform independent. Why? Because when we are creating containers, we are not getting the kernel of the operating system inside our container. We are only lifting and shifting our application and the services inside the container. So, but in contrast to containers, VMs are running on complete operating systems, including their own kernels. But this is not the case in case of containers. Containers are built on top of the host operating system kernel, and they will only contain the app and some lightweight operating system APIs. So that is why it is platform independent and very much lightweight. In case you have any questions, you can type it in the chat window. I'll try to look at them. Okay, now look at this slide. You have a development machine which has its own operating system, application code, the dependencies, and files. Now, when we create containers and move the application, deploy the application in the containers, what we are essentially doing is we are only moving the application, the associated dependencies and files in, and creating a container of that. Now we have that container, which can be viewed as an isolated environment that allows us to build and run our software packages. Okay. Now, this software package that you are creating, it includes the code and all the dependencies which are required to run the applications quickly and in any environment. You can deploy the container on Linux, Windows, data center, cloud, wherever you want. These packages are called container images. Okay. Now, container image is a unit of your software application. Software containerization is a operating system virtualization method, basically, that we can use to deploy and run containers without using any VMs. Containers can run on any physical hardware, VMs, clouds, and multiple operating systems. Okay. Now, the next question that comes to our mind is how do we create containers? We knew how to create VMs, but how do we create containers? Okay, so to create containers, we need Docker. Okay, now what is Docker? Docker is a containerization platform which will help us to develop, run, and ship containers. Now, Dockers don't use a hypervisor, unlike VMs. And we can run the Dockers on any desktop or a laptop, which is a developing machine or a testing application. The desktop version of Docker supports Linux, Windows, and Mac OS. Uh, for production systems, Docker is also available for the server environments, including various variants of Linux and Windows Server 2016 and the newer server versions that we have. Now, Docker platform consists of several components that we use to build and run the containerized applications. Okay. You can just Bing or Google Docker, and you can download it on your development machine. You can install it. Uh, this Docker is essentially required to create and develop and ship the containers that we are developing. Now, there are certain terminologies that are associated with Docker, uh, like a container, container image, build, pull, push, and there's something called as Docker file. So we understand what is container. It is a unit of software or a software package that contains everything that an application needs to run, and it runs on top of the host OS. Container image is the package with all the dependencies that we have created. It includes the framework, deployment, execution configuration that a container runtime uses. Now, build what it means is it refers to the action of building your container image based on the information and context that is there in the Docker file. So, what is Docker file? So, Docker file is something, it is a text file. It is a text file which contains instructions on how to build your Docker image. It is like a batch script. The first line states the base image that you are referring to, followed by the instructions on how to install the required programs, then copy files, and so on until you get the working environment you need. Now, pull and push. Pull and push are the processes of downloading the container image to a container registry, and push is the process of uploading a container image to a container registry. Container registry is a registry which has all the container images. The most popular public container registry that you would have heard is Docker Hub. We also have a private container registry offering from Azure that's called Azure Container Registry that we'll be talking about in detail during this session. Okay, now let's look at some of the commands when we use Docker. How does it look like? Let's say we have a base image, container image name called Ubuntu, and we want to pull the image. So we'll use Docker pull and the name of the image, which is Ubuntu. Let's say you have a MySQL container image that you need to pull. You can use Docker pull MySQL and the version of that. Um, Similarly, let's say if you have a sample .NET application and you know the it's a web path, you can specify Docker pull and the complete path, and you can pull the .NET application. You to run the container locally, you need to use the command docker run and the image name and the tag of that. Now, there may be other containers running on your development machine. If you just want to view the containers that are running, you can use docker container ls -a command. Okay. Now, let's look at a Docker file. I mentioned that Docker file is something that we use that has set of instructions to build your container image. Now, this is a text file which is very important to run and build your Docker container app. So this is called Docker file. Now, if you see over here, the first instruction is start with this container image. This is the base image. Then you are making a directory running this command. You are copying some files and you're giving the path. We are specifying the working directory. And then we are installing npm, which is a node module, which is required maybe for our base image. And then we are specifying the start command. When we are running the container, what will be the start command? All this instruction is given in the Docker file, which is a text file. Okay. Now, to build this container image, we use Docker build the application, the path to build the image, and the tag associated with it. After building, we can also run the command Docker images to view our new container image. Uh, so container runs on a specific port. When we run the container, we need to specify the port. Let's say we are running it locally, we can specify 80. So if you are running on any other port, you need to specify the port over here when you are running the containers. Okay. Now, I mentioned that when we are doing container development, we use base images. We can use the base container images from the Docker Hub, which is publicly available. We can download the images, pull the images from there, or we can also use Azure Container Registry, which is a private container registry offered by Azure to publish our container images. Okay, when we develop containers on our local machine, we can use Azure Container Registry to just push the container image and store it in a private container registry. Now, the Azure Container Registry is also called ACR. It is a managed Docker registry service, and it is based on open source Docker Registry 2.0. Okay. Container registry, uh, it uses your existing container development and deployment pipelines. So the Azure Container Registry is used to build the container images in Azure, and it we can fully automate the builds using the source code commit and the base image update build triggers. Now, just to understand, uh, I'm just trying to change the slide. I think it's not working. Just give me a second. There are some terminologies associated with Azure Container Registry. Mm, Rashmita, can you change the slide?
Yeah, let me try. Okay. It's not happening. So what I'll do, I'll just remove and add your slide one more time.
Okay, okay, sure.
And in the meantime, just check if you can
Hmm.
just change your slide, and then I'll add back to the StreamYard.
Sure, sure.
Yeah. Able to change the slide?
I can't see it right now. Sorry.
You can, I mean, whatever you're comfortable. Let me just bring that slide, Dashleen, if you want to share your screen PPT, if this is not working for you.
Yeah,
Yeah. Let me know once you're ready. I'll bring that on the
yeah,
StreamYard.
yeah. Yeah.
You can make it with a presentation mode for
Mhm.
people so that you're
Yeah. Can you see it now?
yeah, uh down, come down. There is this button, or yeah.
Can you see it now?
Yeah, I can see.
Okay, so I was talking about some terminologies that are associated with Azure Container Registry. Sorry for the glitch. So these are some of the key terminologies. Registry is basically a service that stores your container images. Repository is a group of related container images. Okay, now image is something, a point in time snapshot of that Docker container. So whatever development we have done, we build and create an image of that. So that's called the image. And container is the software application package and its dependencies that we can run in any environment. Now, one thing to note over here is can you I'll just stop sharing and start sharing again.
Yeah, probably you have to make your presentation in the presentation mode because we could see the notes. So
Mhm. Okay, let me know once you start seeing the presentation.
yeah.
Okay.
Yes. Is this the slide you were referring to? Docker container
Yeah.
and registry?
Yeah.
Okay, yeah.
So one thing to note over here is when we say repository and we mention Azure Container Registry, uh, it has a public URL. It's a fully qualified domain name URL that we have. It is let's say the name is my registry, so it is myregistry.azurecr.io. The FQDN is azurecr.io that we'll be using. That's the repository. And if you look at this image, you have a repository of the container images that we can create inside our Azure Container Registry. Once we create ACR, we can upload our container images inside the repository. Okay. Now, okay, because it's a private container registry, uh, it is built, it's chargeable, and there are three container registry offerings. One is basic, standard, and premium. So basic is just for the learning purpose. For prod or the more higher programmatic abilities, we need to use standard and premium. Standard has all the capabilities of basic, but it has more storage limits and image throughput. Premium is when we need geo replication across different locations or data centers, and it has more enhanced storage capabilities to support high volume scenarios. So these are the three offerings from the container registry. Now you can directly create a container registry from the portal, or you can use a CLI command like azcr create, the name of the ACR and the SKU, basic, standard, and premium that you need to create. Because it's a private container registry, we need a login for that. It's secure, so you need to have a login ID and password for it. You'll have a username and password. Okay. Now, because I mentioned in the beginning that Azure Container Registry is based on the Docker platform, Docker 2.0. So all the Docker commands that we looked previously, we can run those Docker commands on the Azure Container Registry as well, like Docker pull, Docker tag, or Docker push. You can also view the list of the container images that are already there on your ACR. Uh, Easy ACR list. You can deploy the container images using the Docker commands. You can list the container images, ACR repository list, and you can view the specific tags associated with them as well. Okay. Uh, I'll just check the chat window once if you have any questions. Okay. Okay. So let's move on to the next slide, which is if you want to enable the admin user, we need to update the ACR. We can run the CLI commands for that as well. AZACR update or AZACR credential show for querying the password. If you want to deploy the container, it's AZ container create, and you can view the container FQDN as well using container uh, AZ container show. Okay. Now, one feature, there are suite of features with container registry. However, one feature is it provides fully automated builds with the source code commit and base image if we update with the build triggers. So, if we have developed a container image and we have deployed it, and later on we are making some changes or code changes to our container image, we can automate the trigger the builds and automate it immediately. The changes it will get built and the changes will start reflecting in the ACR as well. Okay, so in production scenarios, particularly, we use service principals for our container registry access. However, you can use admin user based on login username and credentials. You can use AC container create to create the containers. You can trigger the builds. So let's look at the command over here. This is your development machine. If you are making any changes to the code, you will give the command ACR build. That there's a build agent that will trigger the build inside the container image, which is there in this repository, and the new changes will start reflecting. So ACR build your image and the registry that you are referring to. You have to provide that path, and that will trigger the build for your ACR. Okay. Now, coming to the last part of this presentation, we have an offering in Azure which is also called container images, Azure Container Instances, that is called ACI. ACI is basically, it helps us to create and run the container images. So initially, we looked at the VMs. We could create VMs and deploy them and deploy our application code and just run them. Then we had come to an idea of containers where we could just use the container, the application and the dependent files, lift and shift them using the Docker platform to any of the platforms based, be it Windows, Linux, or any cloud or server instances. Now, to run the containers, we had to create some machine, or we had to create a virtual machine on Azure and run the containers or the Docker on them and set up the machine to run and support our container images. But there's an offering from Azure which is called Azure Container Instances, which helps us to get rid of all the headaches like installing Docker, etc., to make our machine app container ready. So, let's simplest way to run the container in Azure is ACI. It does not require any VM provisioning, which is infrastructure as a service (IaaS). It doesn't require any adoption of higher level services, like you don't need to install any Docker or something. Uh, Once you deploy a Azure container instance, it supports Linux and Windows containers. It is already ready to run your container applications. So it already supports Docker. It is a good solution for any scenario that we can operate in isolated containers, including the simple applications or task automation or build jobs. Now, for scenarios that we need full container orchestration, including the multiple containers or automatic scaling. For that, we recommend Azure Kubernetes services that we will be covering in the next sessions. But for simple applications or any task automation or build jobs, you can simply use ACI. So if you are you can also create some container groups inside the Azure container instances. uh, a container group is a top level resource in your ACI. Now let's say you have two container images. One is web, which is running on port 80, and the other one is a SQL container image, which is running on port 1433. You can create separate container groups in your ACI. It is a collection of containers that get scheduled on the same host machine, and it shares the basically same network lifecycle and storage volumes, but it's just a isolation. It is scheduled on a single host machine. It is assigned a DNS name. It exposes a single public IP with one exposed port. Now, you can have two containers. One container is listening as shown over here on port 80, and the other one is on 1433. Okay, so this is called grouping of containers. Why do we need ACI? We can simply provision a machine and create containers using Dockers. But there are some benefits of using container instances, like fast startup times. You don't need to provision and manage the VMs. You get a public IP connectivity and a FQDN name with Azure Container Instance. Uh, you have a hypervisor level of security. It is available in custom sizes. It is available for Linux and Windows containers. You can use the same API for both type of containers. It should support scheduling of multi-container groups that share the host machine resources. Now, one advantage over here is container instances can be deployed into an Azure virtual network. Let's say you previously had a virtual network already there. You can deploy ACI uh, on the Azure virtual network. Okay. I mentioned that you get a public IP connectivity and a DNS name. So it looks like Azure region dot Azure container dot io. So if you see a URL, something with Azure region dot Azure container dot io, that means you are using a Azure container instance. You can deploy your containers to container instances. You can get the name of your container registry using AZACR show. Uh, Using AZ container create, you can deploy the container into your ACI. Okay. If you have any questions, you can type it in the chat window. You can verify your deployment progress or view your application URL using AZ container show. And you can also see the container logs, which is very important, which is AZ container logs is the CLI command for that. Okay. So that is all about the containers and how to create container images and how to deploy them on Azure. We have You can deploy a simple vanilla machine and deploy containers and deploy your container images on that. You can use private Azure container registry to build and automate your changes. The last one is you can use Azure container instances to deploy your container images. Um, with that, we come to the end of our session for today. Uh, we will also be discussing about Kubernetes in detail in the next sessions. So in case you have any questions, we can just check the chat window.
I think there are two questions, Dashleen. I'm not
Mhm.
sure whether you've taken it or not, but let me bring that for you on the
Yeah, sure.
screen. Yeah.
What is
You can see the
container and
question. Yeah.
yeah. What is a container and a image is the question, right? So going back to the slide wherein I explained what is a container basically. So container is a very popular concept these days. What is a container? So earlier we used to create virtual machines. For the virtual machines, it used to run the complete operating system and the along with the kernel. So let's say if we had a development machine which was running Windows operating system, we use hypervisor to create a virtual machine. Our virtual machine will also run the Windows operating system. Entire operating system along with the kernel will be copied to our virtual machine. Now, then came the concept of containers, wherein we had the host machine. Okay, we had the Windows machine, let's say a development machine. But when we were creating containers, we were not copying the operating system and its kernel to our uh, container platform that we have created. So if you just want to, I'll just go back to that slide. If you look at this diagram, yeah. So if you see over here, the kernel sits outside the container. What we do is we create the application and the dependencies. We package them inside the container. What we are not doing is when we are creating containers, we are not copying the entire operating system and its kernel files into this container. Okay. Uh, how do we create containers? We use a platform which is called Docker. So, Docker is the platform which will help you to create the container on your host machine. This container will have your application code and its dependencies. Now, once you create the container, after you have created a container, which is the unit of software, which is the application in that you are supposed to run, you will build it using Docker. And the package that you have created is called the image. It has the application, the dependencies which are required to create the container. These dependencies include the framework and the deployment and the configurations that your container needs. Now, image is immutable once it has been created. So we can use these images, we can use these container images and deploy it on any platform. That's basically the package that we have created. Um, Next question.
Yeah.
Container versus PaaS. So PaaS obviously is more cost effective, but it depends upon how many workloads are you running. Let's say if you have a simple web application that you want to run and you need a public facing URL and you're not bothered about managing it, you can go ahead with the Azure App Services, which is a PaaS application, PaaS offering from Azure, and that would be cost effective instead of creating container for this particular point of your application. But let's say you want to run your images on various platforms, and you have different kinds of images, like you have a web application, you have a MySQL image, you want to keep on changing the code, automating the builds, and all that, then you go for containerization of your applications. And if you want to be more private and in a secured network, like a virtual network, you will go for containerization. PaaS won't allow you that. So it depends upon the architecture of your application and the need. You need to analyze the cost and optimize it according to the requirement also. Yeah. Next question. No, you won't be able to have the access of this presentation because it's Microsoft priority and I can't share this. However, all of this content is in Azure Docs. If you just Bing or Google, you'll be able to see the content. All of this content is from the Azure Docs. Azure Spring App Services, are you talking about a Java application? or just the Azure App Services? You can bring in the next question, Rashmita, till that time. Okay, just the
I don't.
Azure App Services. He's mentioning just the Azure App Services. So, just the Azure App Services, if you are not bothered about running your application in a virtual network, you don't want to, you need a public facing URL. You want to deploy your application in many other locations across the world. uh, you need just one FQDN. You need everything to be managed by Azure. You do not want to manage any server, operating system, etc. You can just deploy your application in Azure App Services, and you'll get a URL, public facing URL, and you are live. So you'll go for Azure App Services, and that's a PAAS service, which is platform as a service. So everything will be managed by Azure. You can only choose the operating system that you need, but you can't update it or upgrade or specify the particular version because everything is managed by Azure. I think there are no more questions.
Yeah, we don't have any more questions. So while we are waiting for another 2 minutes, if you have any
Mhm.
question, please feel free to drop in the chat. Dashlin is here. She can answer to those questions.
Sure.
You can also reach out to Dashlin if you have any further question. Probably I'll share Dashlin's LinkedIn social handle for you folks so that you can reach out to her. I've just shared in the chat her LinkedIn handle. If you have any question, please feel free to reach out to her. Okay, so I think we don't have any more questions, Dashlin. So thank you so much for hosting the session at Reactor, and thank you all for joining us today. Please do
Thank
share
you.
your feedback about today's session. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again and enjoy the rest of your day.